Good morning, my name's Alex Stanhope and this is the second in a series of talks about a positive future for AI, why we shouldn't be afraid of it and what we can all do to be prepared for it. The theme of this talk is training, both of human beings, what I can do to be ready for AI, but also of how AI works and how it's trained. I want to talk a little bit about how AI thinks. It's often talked about as artificial intelligence, but a closer model, I believe, for our AI is artificial intuition. So I'm going to talk about the little bit between what is intuition and what is intelligence and how those two relate, and then also how AI is trained and how that works differently, fundamentally, from the way human beings are trained. This is the outline of Sir Winston Churchill. In the 14th of October 1940, the Churchills were dining in number 10 Downing Street. Mrs. Landermere was preparing a pudding in the kitchen and was most put out when Winston issued an order to say that all staff must leave the residence and instead go down to the basement. Moments later, a bomb struck the old Treasury building, blowing out the windows of the kitchen, which would have killed all the staff were they in there. Mercifully, the Churchills and all the staff of number 10 survived. And it went down in history as being one of those moments where an intuitive call saved lives. Now, we encounter intuition in a whole variety of different fields. To characterize it as magic is unfair, so I would say intuition is not magic. Churchill was a cavalry officer and had spent a long military career in positions of danger and had a good sense developed based on lots of previous samples, experience of previous situations that allowed him to hone this intuition. Intuition is defined as the ability to understand something immediately without the need for consciously reasoning it. And it's that sort of instant understanding that I think is the closest model for how AI works, rather than sort of logical reasoning, which we might do as human beings. I want to talk a little bit about the Bake Off. So this is the Pillsbury Bake Off, and Sue Compton in 2010 was clipping coupons in her newspaper and saw an ad for the Pillsbury Bake Off and decided to enter. So she just went to her kitchen, produced a dish, wrote down the recipe and sent it in, and her mini ice cream cupcakes were incredibly successful. In fact, she won the competition, netting over $1 million. What she said about the experience was interesting. So she said that I just let my mind relax, not knowing what was next. There is an intuitive process that she went through there. Now, it's not intuition based on nothing. Much like the Churchill example I gave, both Compton and Churchill were highly trained in their fields. Sue Compton had done a lot of baking. She understood very well how to bake and so on, and had built those neural pathways in her brain. She had, if you like, looked at dozens of samples, maybe even hundreds of samples of previous recipes she'd used, things that had worked, things that had failed, and she'd used that to learn this highly honed set of baking skills that she then used in that moment, without really thinking, to create this award-winning recipe. AI works in a very similar regard. So rather than thinking through something or rationalizing it or logically arriving at it, AI will look at dozens of samples, but dozens doesn't do it justice. It's on a scale that's very, very hard to fathom. These samples look a little bit like this. Here, if this was for a self-driving car AI, what we would do is we would show it images, frames of video, as this was taken, that give it a rough indication of the kind of things it will experience, and then these frames of video are labeled. You'll see on this there are cars and traffic lights labeled, and these instances allow the object recognition as part of that artificial intelligence to work out what different things are in the scene, and then use other sensors and other information to make a judgment as to what's happening with those, and build a 3D model for the scene, which it can then use to safely pilot the vehicle. Now, it doesn't do this in isolation, and it doesn't do this based on a few dozen images. I thought I would ask AI to come up with an answer to tell me how many images it would need to see, and this is the answer it produced. Again, ChatGPT-3 delivering an answer in about 3 or 4 seconds that is incredibly accurate. For image classification with convolutional neural networks, or CNNs, are gaining a lot of traction at the moment, it might be something like to 1,000 to 10,000 labeled images. Image classification is in that, like that previous example I gave, each one of the cars in that scene was being classified as a car, which is one of the first steps in building this model, this perceptual model of what is happening in a scene, which then might allow the AI to drive safely through it. In things like natural language processing, which might use recurrent neural networks or transformers, that data set was even larger, 50,000 to 100,000 labeled sentences that allow it to understand what's going on. And in all these things, it really is just the tip of the iceberg. ChatGPT-3 takes that to yet another level, 300 billion words in its training data set. Now, to put that in context, that's a lot of words. Shakespeare, the complete works, comes in at just under 1 million words, but we're talking here about 300,000 times that volume of information in just its training set, just the information it parsed to build this perceptual models that I talked about in this series. Now, ChatGPT-4, 13 trillion words and tokens. The tokens also include things like code words and things. Now, that is, it speaks to the sheer scale of evolution here, that the training set of that size is being used to build this this artificially intelligent network. But I would argue that it's artificially intuitive rather than intelligent. When I ask it these questions, it uses the input. I talked about inputs and outputs again in the season. Please have a look at that if you'd like to get more information on that. But it uses those inputs and a context window. Started at about 2,000 words. It's now up to about 32,000 words with ChatGPT-4 to build up an understanding of what it is that we're talking about, and then use its inputs to inform its outputs, and that's what we see in the generative data that it produces. AI is very good at that sort of thing. It's very good. Its breadth of knowledge is enormous because it can take these huge training sets. It can recall data from them instantaneously, primary and secondary memory within only a few milliseconds, and then tertiary memory of petabytes in scale within only a few tens of milliseconds. It can analyze those things in parallel. So when we give it a huge training set, a little bit like the monkeys with typewriters, we can break it up into lots and lots of small pieces, and an artificially intelligent system can task workers to analyze a small part of it. That's how we get to numbers like 13 trillion words. It's not that one computer got very busy for a long time analyzing 13 trillion words. It's that whole networks of computers with hundreds of processing cores were working away at that to produce the AI model that is behind ChatGPT-4. It's very good at iterative refinement, so it will be able to progress that and advance that so that the model develops a greater and greater accuracy. And by that, it's not an accuracy to its training set, but almost the underlying fundamentals of that training set. What words are used with other words, and not as simple as, well, normally after and it says then. It's not quite on that scale. It's big because there are billions of inputs and these networks are incredibly complicated, and the context windows are not just 2 words but 32,000 words. We're ending up with a very, very complex and well-formed sentence as part of well-formed paragraphs, as you saw in that previous example, that overall give a really good understanding. And that's how generative AI produces what are extraordinarily accurate results in very short spaces of time. It's generative as well, which is exciting because it can take a random number as part of those inputs and use that to produce many billions of different outputs based on the same set of input text. If you've played with any of the generative AI tools like DALL-E, then you'll know that the same set of keywords, you can hit generate a bunch of times and it produces a different image every time. Those images aren't always perfect. There's a little bit of hallucination in there. It produces human beings with too many fingers often, but it's incredibly close, and it produces an image that is extraordinary, given that we're talking about something that is being created from almost nothing. Other than it's not from nothing, it's from a set of previous works, and that's the essence of this talk. These training sets are what informs AI, and the big leap forward we've made with AI in the last 10 to 15 years has been on the computing power that enables to process larger and larger training sets and therefore produce more and more intuitive artificial intelligence. AI isn't good at everything, and one of the things I'm trying to do to prepare for AI is to get good at the stuff that AI is not good at, because that sort of specialization I think will help me hopefully stay relevant in a world where incredibly smart artificial intelligence is becoming more and more pervasive. It's not good at creativity. Now, that's not to take anything away from the generative AI that is producing new works, producing new songs, producing new videos, but instead to recognize that what it's really doing is taking things that existed already in its training set and combining them in ways that we hadn't seen before to produce something new. That kind of derivative work is not without merit, and I'm not criticizing it, but I am recognizing that it's not I would argue it's not creative in the same way that some of the greatest human minds have been able to create things. So thinking of Mozart's and Da Vinci's and maybe these minds that have been able to produce new things from nothing, or I know from previous experience, but previous experience in so many different areas. One of the areas that AI is not good at is generality, whereas we as human beings, because we experience things in so many different areas, not only the specialisms in which we all work, but so many other areas, we can combine those things to create new things well beyond the scope. AI isn't good at reasoning or inference. Now, I know people would argue against that, and that's completely fair, but I'm talking specifically about the kind of reasoning that says, well, I have this predicate and I can derive from that this, and then this, and then this. You can train computer algorithms to do that, but the kind of artificial intelligence I'm talking about so far doesn't currently do that well. This is all what's going on presently, and I know that I'm talking into a fast-moving field. So in a few years, maybe even only a few months, many of these things will change. But for now, that reasoning and inference isn't coming from these intuitive networks, because while they're very, very good at seeing things or generating things within their own sphere, they're very poor at moving that forward. And that's partly because the network's very good at saying, given this input, I produce this output, reference to the functions that I talked about in the first session, and not very good at saying, well, that produces this output, which then means this, which then means this, which then means this. They don't create good transferable knowledge, so they don't have the ability to learn something in one area and then apply it to another area. If I train an AI to tell the difference between bagels and bananas, it will only tell the difference between bagels and bananas. And I may be able to get the success rate for that up to, a very high level. I think, sort of 98, 99%, very, very high percentage of accuracy. If I show it a picture of a monkey, it won't be able to say that's a monkey, or it won't even it will probably misclassify it to say that it's a bagel, because it will only be looking for the difference between bagel and banana. This lack of generality means that it's very, very specific what it can do. And one of the things we have as human beings is to move, hopefully, beyond that and be able to combine things outside that. And as I say, this won't persist forever, but this is just the situation we're in now. AI isn't accountable. So for all that a self-driving car is technically possible, and we're already seeing fantastic steps forward from the major tech companies, we still have a fundamental issue of accountability. Human beings are accountable, but at the moment, we don't have a legal framework to make an AI accountable. So what happens when if that car crashes into me? How is that AI responsible for its actions? What are the consequences to it if it makes a mistake? These are all things I think about when I get in the car, but an AI will simply be going, I'm seeing this image, how can I traverse this intersection in a safe way? Where are the other cars? What are the traffic lights saying? We need to find ways to manage accountability, because it's that accountability that allows us to take action in the world. Locality and presence shouldn't be underestimated. As human beings, we like interacting with human beings. They are there is a feel to interacting with an artificial intelligence that can feel a bit alien. Some of the examples I gave in the previous talk of the Terminator and HAL from the movie 2001: A Space Odyssey. These are examples of very alien feeling people. Well, sorry, not people. Intelligences. And I think that one of the things human beings do well is relate to other human beings. In this talk, I think 30%, something like 30% of what I'm saying is actually the words I'm saying, whereas hopefully what you're taking from it, there's another 70% of non-verbal cues, the intonation I'm using, the way I express myself, and hopefully that is contributing to a rich communication process, but not all of that is accessible to AI. And so far, synthetic human beings generated by AI have felt synthetic. We're very sensitive to that. There's a principle in computer vision called the uncanny valley, which is that when you create a model of a human being that is a cartoon, we as human beings are quite happy interacting with that cartoon because we know it's a cartoon. It doesn't look like a human being. Whereas once it starts getting close to looking like a human being, we just get this weird sense that something's not quite right. It's the reason why special effects in movies are so difficult, because if they're close to being right, we can tell that it's just not quite there. Which isn't to say that actually that technology hasn't moved forward amazingly in the last 25, 30 years, and now special effects are of an incredible standard. The theme of this talk was how to prepare for this positive future, and the message is training. Whether you're an artificial intelligence or a human intelligence, the importance of training is absolutely paramount. I feel like we belong to different generations, but I would say while my grandparents' generation and to some extent my parents' generation were able to train up to the age of 18, 21 and achieve some qualifications and then apply those skills through their working life, for my generation, for my children's generation, I don't think that's true. I think we're instead pressed to be constantly developing new skills, learning new things. And so I'd argue that there are two types of things we can all do to prepare for AI. In the short term, it's about using it, it's about building it into your process, so better understand the AI outputs, learn how to shape your inputs, those AI prompts, effectively to get the outputs that you want, learn how to embed it in existing value-adding processes so that you're getting the best of this intelligence while it's developing, and understanding like how to use it and what it can add. In the long term, ultimately, I think it's all just about development. It seems like the pace of technological change and human change is accelerating, and we all need to develop. Every day I spend a certain amount of time trying to develop some new skills, trying to learn some new things, trying to understand some new areas, and my ability to do that is what I monetize through my consultancy. But I think that the amount of time I dedicate each day to learn new things is going to have to increase. Crucially, over the course of a week or a month or a year, so much of the knowledge I have is becoming outdated that I need to learn more things in order to be useful to the clients that I support. The rate of change and our adaptability will need to improve as well. While before it was possible for the same value-adding tasks to be done in the same way for a long time, I think the time scales are shrinking, so that the task evolves in itself, and all of this new technology and an increased competition from across the world, Brazil, Russia, India, China, vast numbers of human beings who are able to compete and get access to these technologies as well, means that we need to drive our rate of change and adaptability and be agile. Talk a lot about agile in management consulting and in the development of technology-driven products. Agility, while sometimes just mentioned as a buzzword, is also fundamental to our approach, I think, as a species to AI. We need to work out what works, work out what's not working, reduce the risk in taking new steps, but boldly take those new steps. If we're not trying new things, which of course is a risky process, then I'm often not learning, and I feel like I can't therefore add value. Finally, the thing I'm trying to do, and I think to some extent we're maybe all trying to do, is to specialize in less substitutable skills. So if I were doing something that I know an artificial intelligence will do very well, then the length of time I might be able to carry on doing it is shrinking as that intelligence gets better. We've seen this, this is not a new thing. This has been happening over decades in sectors such as manufacturing, where we've seen robotic process automation make a huge dent in the way almost all of our goods and services were produced. That's not particularly contentious, I think, but I would argue that human beings haven't been replaced. The key things in that human beings in advanced manufacturing are being driven into the area where they are specialist. So having a human being do a robotic action repeatedly, hundreds or thousands of times a day, adds little value when they can be replaced by a robot. The key thing is to work out what we can do to specialize in our areas and continue to make this journey into AI one which is positive for us as human beings. And I hope that this talk has been a small part of that. If you've got any questions or comments, please let me know. And thanks very much for watching.